Hello, Internet. Today, I'm going to be learning Google's new Tensor Flow graph computation engine. They say you can use it for neural networks and all kinds of other things. I'm just going to be trying it out while using my workflow. Let me switch over to my actual desktop here. Hopefully that works, and if it doesn't, we'll catch up in a few seconds anyway. Delightful. Alright, so we need to install TensorFlow here, of course. So I'm here at the TensorFlow website, and that's the first problem of anything. This is sort of going to be the first in hopefully a series of Dan Does Data, trying different kinds of learning environments and tools, things like that. I saw TensorFlow on Hacker News. I saw it came out today or very recently, so I want to try it out, see what happens. I want to get started. I haven't read any of this. All I know is I read the main page. That's what we're working with. If you have something that you want me to try out, or if I'm doing something really wrong, you think that I'm an idiot, tell me in chat. Send me an email. Whatever. Not on Twitter right now, so you can't do that. I'm sorry. Yada yada yada. It's all in Python. That's super great. Makes my life very simple. What are they doing here? They got pretty good comments. Making some two-dimensional data points, building a stupid model out of it. And they're doing this as a graph. Okay, so that's the cool thing. Interesting. Yes, and you might notice I have this hover zoom installed. That's really for browsing Reddit. I can look at images much more quickly then. Hover over it, boom, get the full size. It's great. Interesting, you can... The blue pill, the red pill. I'm not going to worry about either one of those. Download and setup. I'm really hoping I can just pip install this. Oh, requires Python 2.7. Oh, this could be nasty. This is going to be nasty. Alright, I'm going to see if there's a version for Python. That's a binary. Maybe there's another version. Oh, come on. Google. You were doing so well. You were doing so well. Python 3? No. Misery. Alright, new tab. Let's see if there's someone has created this. Python 3 Tensor Flow. What do we got? No. Data structures, no. Google TensorFlow. No, I only want the ones for Python 3. This might kill this stream right away. This could be dangerous. Alright. I guess I'll use some kind of virtual env and I'll tolerate Python 2 usage today. That's something I really like to avoid. Python 3, there's things that I like about it, there's things I don't like, but it's the future, so I prefer everything to be in Python 3. I don't know why they chose to use Python 2. That's super unfortunate for them. Alright, so if I were to install it, yes, I want a GPU enabled version. Only if you have CUDA SDK. I assume I do. I have a GPU enabled machine. I've used it before. Let's try to pip install this. See what happens. Not a supported wheel on this platform. Oh, bummer. Alright, what other options for installing this? So this is the first problem with TensorFlow, it turns out. It might be switching to learning Theano today. Support running in Docker. I don't actually have Docker set up right here. Virtual env. That's not bad. set up in the directory in Tensor Flow, virtual env, yada yada yada, cd Tensor Flow, source bin activate. What's my virtual env? That's what we'll find out. Virtual env, not installed, of course. Oh, well they know how to, they show me how to install virtual env at least. But Python. Yeah, let me just say Arch Linux, the Linux I run. Sometimes called hipster Linux. It lets you do whatever you want, and also it lets you do whatever you want to yourself. So good and bad. You can see all the websites I happen to have been to recently, mainly going to email and whatnot. Arch Linux. What did I want to say? Tensor Flow. Let's see if anyone has done this before. There's a danger of trying something very new. It looks like no one has tried this. Okay, maybe I'd be the first. That would be cool. Not happening. Alright, Arch Linux. Virtual env Python 2. Because I don't want Python 2 to be my normal Python. That'd be awful. Not what I want. Basic usage, virtual env, Python 2, virtual env for legacy version. That's what I want. So we come back here with Pacman. Install that. I'm running, in case no one has noticed or I haven't told you, I'm running this in tmux right now, a terminal multiplexer. So I can bounce back and forth between these terminals. I can make new ones, I can get rid of old ones. There's other pages, windows they're called. So it's very nice for having a full screen terminal that I'm just in there. I'm not wasting any window space. At the bottom I've got some general information on what my windows are, what time it is. You'll notice the time is probably wrong. I don't worry about that. I have an actual clock and I gotta watch. So not a problem. Let's Pacman this. Yes, my password is Hunter2. Always like the Hunter2, my Hunter2ing. Yep, we'll install that, no problem. Alright, now I got Python 2 virtual environment. What the heck was I going to do to use this? They say I can virtual environment this here. Haha! I don't need to pip install it. I installed it the old-fashioned way. Which virtual env? Virtual env not found. Why is that? Arch Linux. Python 2.6 and 2.3, C Python, Python 3 for overview of different versions of Python. That's not what I want. I want my Python 2 virtual environment, man. That's all I want. Basic usage. Oh, okay. Create the virtual environment. Which Python 2.7. Ah, so I have Python 2.7. Okay. Let's copy that. Let's just call this TF for Tensor Flow. Make virtual environment not found. Great. Virtual environment wrapper usage. Is that a special thing I don't have? Packages a wrapper for both yada yada yada. Alright, but I don't have virtual env working in the first place. Or try the archive link. This is just the package information, that's not helpful. Virtual env, my env. Why do I not actually have it? VN? No. Alright, let's start. Pip 2, is that a thing? No. Which pip? User bin pip 3, pip 3.5, and they're almost the same thing. Okay, that's cute. Alright, how do I use this then? Again, I apologize. I was really not expecting them to be using an outdated version of Python for their brand new tool. That's pretty strange, if you ask me. They're using easy install to install a virtual env here. That's not really what I want to do. Blah blah blah, 2.5, 2.5. God, this is a Windows description. This is horrible. Activate the, alright, I don't think this is what I want. And of course, you guys are probably seeing things on there that I'm not, I'm missing it entirely. That's okay. That's the nature of streaming, I think. You don't see the super obvious things. Anytime I watch streamers, like I'm watching Day 9 or something, he's missing the super obvious thing. So frustrating, so frustrating. How do I actually, you know what? I'm just gonna have to search a new tab. Arch Linux Virtual Env Python 2. Yeah, that's where I've been. Python 2.virtualenv. I have that plugin installed. Yeah. Python 2. Like, I don't have virtual env at all. So why is that? What happened? This is how I can go back through my history in Tmux pane. I installed Python 2-virtualenv. So you would think that would show me what I got. Perhaps that is not the case. Required by virtualenv. Is this an AUR thing? Alright, whatever. We'll just install the virtualenv wrapper. It's all good. It's all good. Maybe that'll make my life easier. The danger of this Arch Linux. I'm gonna start installing packages that I think I need, because shit's not working otherwise. Alright, make virtualenv, yada yada yada, command not found, of course not. Why would it be found? I made a new Tensor Flow. There's nothing here. Virtually env. Oh, yeah, now it works. Okay, just I didn't have it. Didn't realize it was in the path. Okay, we are going. Don't need you. Don't need you. What am I doing here? We're going here. We're going here. I lied. -- system site packages. Alright. System dash site packages. And whatever I want my thing to be, I want to call it TF. Installing setup tools, pip, yada yada yada. Okay, great. Source bin / activate. Okay. And I'm in Z shell. It's close enough to bash. Alright. Bam. Now I'm in TF. Great. Now I can install Tensor Flow. Okay. So now I pip install whatever this hootenanny is. Let's try that. Oh, not supported on this platform. Is it only Ubuntu? That's going to be another deal breaker. That is going to be another serious deal breaker, my friend. What's the problem? Additional images. Do I really want to install Docker to make this work? Maybe. Maybe. Alright, fine. Let's try the CPU only version. Maybe that's the problem. Even though I have a GPU and it's all fine. Maybe I don't have the CUDA SDK installed. I thought I did. No. What does that look like when I go there? What is it? Does this tell me something about it? No, I don't want to do that. Just tell me about it. No, stop. Come on, guys. Oh, great, XML5. Okay, never mind, that didn't work. Alright, what about, like, install from source? That's what I want. Using pip. Yeah, that's great. What about, yeah, let me compile from source or something stupid like that. Try your first, run your first. Installing from sources. Hey, here we go. Oh, I can just git clone. Well, that's much easier. Installation for Linux. Install Bazel. What is this? Jesus Christ. Download install CUDA. Download this. Download that. Download this other thing. Go crazy. Create the pip package and install trainer. Alright, well, we're gonna try this stuff, and if it doesn't work, I'll just waste it a shit ton of time. Let's do it. I'm in the virtual environment. I don't know if that's gonna matter now. Cloning some stuff from GitHub. Take a little time here. We're going. Making some progress. Alright, I'm gonna learn about stream cards on YouTube. See what the hell that means. What does this mean? Alright, we're almost done. Done with that. Bang, 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 bang. Okay, Google Proto Buff. Funny, that's really funny. Okay. Installing from sources, installation from Linux. So now I've got whatever this thing is. Tensor Flow. That's interesting. Let's take a look at the README. Hey. Actually, you know what? Ugh, I don't have quite enough. There we go. Okay, that's a little better. Open source library. Not accepting pull requests. Doing ISO tracking. Install the CPU version using a binary package. Yada 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 yada. Let me find it on GitHub. Maybe someone else has posted an issue. GitHub Tensor Flow. As we've been going for 20 minutes or whatever and not making any progress on using Tensor Flow. It's well, maybe someone on Hacker News where I found out about this knows. Tensor, yeah, there we go. Someone have comments here? Yada yada, they really love it. It's super good. Requires 2.7, yeah. This guy has the same feeling that I do. Ah, they're working on Python 3 support. Okay. People comparing it to Torch, that's a more specific neural network interface, just like Teano, other things that I'm gonna try streaming about. People are trying it out, open source library, yada yada. Clarify single machine. Alright, so someone else has noticed that they don't have Python 3 support. So I'm just gonna +1 that yes, I really want Python 3 support. It really is this the main problem? Just that it needs to be like Pi 2 to 3 done on it? Alright, well I'll comment with a +1 saying, hey, I want that. This is what I get for doing bleeding edge. As typical with Arch Linux. Alright, do they have any different information here? I don't think so. This is about the same. Yeah, okay. Alright. So what was the other thing I needed to do then? I need to install Bazel. Download and build the Bazel source with the following commands. Jesus. Is there another issue on here? Too closed. Really? Fails to import with protobuf something something something. No. Seriously, why is you know what? Maybe I'll try the pip install thing again. Actually, let's go down one. Pip. Yada yada yada. What does it say? Not a supported wheel on this platform. Alright, so Arch Linux. pip not a supported wheel on this platform. What do we got? What do we got? Yes, Stack Overflow. The font of all knowledge. Let's just open up a couple, see what we got. Someone's trying to install PyPi, which I was fighting with yesterday. And they're saying, no, that doesn't work. Means SciPython C3 3.3. You need something else. So is it just that I don't have, what's which pip? Pip dash version. Pip 7 something, yada yada yada. Why is it Python 3.5? That's not what I asked for. Why you gotta be doing that to me? Alright, so I've got the wrong Python here. Bin, nope, source bin / deactivate. What's the rule here? Deactivate. I could have sworn that was something. Exit. Well, that was wrong. Kill that one. Okay. Raj, so that's Tensor Flow. So I had somehow, with my virtual environment, created a Python 3 version as opposed to Python 2, even though that's not what I asked for at all. As I said, Python 2.7, clearly right there. It claims it doesn't know what make virtual environment is. That's a lie. Virtual env v-version. All right, help dash python dash python. Oh, okay. Maybe that's helpful. Dash python equals python 2.7. Aha. What did I actually call this? Dash system site packages, and let's call it tf. If I call it tf, I'm gonna remove whatever's in there because that's wrong. Make it again. Let's try this. Select set of tools, pip, all this other fun stuff. Source bin activate. All right. Now if I say python dash version 2.7, okay, now we're getting somewhere. Pip dash version python 2.7. All right, maybe this will work now. Well, now I want to get greedy and I want the GPU version. Again, sorry for all this. It's very surprised that they released Python 2.7 version first. I think that was a bit of a mistake on their part. I understand sometimes that's what you start, that's what you've been going with. But all the future tools have been going to Python 3. I find it strange, and I hope they have a good reason for that. Okay. Now we're downloading with pip. Things are happening. Life is good. Take a drink of water. That's good. We're cooking, doing the stuff that we gotta do for NumPy, because it's all the virtual environment. Yeah, maybe I should try to learn Docker. Maybe that is the real lesson here. Oh, hi, John. Yeah, what am I looking to achieve with TensorFlow? I'm just trying it out. I want to see if it's something I like. I've poked at Theano as a pure neural networking framework. I like to do random data science stuff. I want to see if this will be interesting. I saw it just came out, so I thought, oh, why not try it? So we'll see. So far this 2.7 is a little frustrating. I made the switch to Python 3. I guess it was about 3.5 years ago. There's definitely things that frustrate me about it, but I made the switch. That's what I work with now. Okay, we've got TensorFlow, nominally pip installed. We should be good to go then. Basic usage. Overview, computation graph, stuff I can read. I don't want to bore you guys with me reading. Let's just see if it actually installs. If it worked. I like which IPython do I have? Shoot. Shoot. Pip install IPython. Yeah. I'm not gonna try to do this in regular Python interpreter. IPython is one of those things that I have to have. Version. Yeah, that's normal. Come on. Is that wrong? That's wrong. Yeah, that's one exit. Let's see, bin. There we go. IPython 2. That'll be fine. Perfect. Actually, maybe that's not perfect. Which IPython 2? Okay, no, that's fine. IPython 2. I'll live with that. Okay, so I'm gonna open up a new text file. That's just TensorFlow test. They say that I should import TensorFlow as TF. I like that. I use Slimux here. So from my Vim session, I'm just going to hit a couple keys, and it will send that line over to my IPython session. So bang bang, it opens up this thing at the bottom. You can see all the panes I have open. So I want to send this to session 0, window 0, pane 0, which will be this pane on the left. Boom! Things didn't work out so well. Okay, maybe I don't have the CUDA SDK installed. I thought I did. My mistake. Let me just use the... Well, let me see how hard it is to install that. Back to download and setup. What do we got? Virtually Ubuntu Linux again, yada. CUDA SDK. Arch Linux CUDA SDK. Let's try that. Alright, I don't need that. I don't need that anymore. I don't need that. I'll leave that open. GPU. That's not exactly what I had in mind. What's going on? CUDA Arch Linux. That's sort of... Try not to just blindly install packages that I think do what I want. Oh, provides. Okay, maybe this is what I want then. Just Pacman CUDA. Okay. Sure. Let me do this in a new thing here. Jesus. All right, we'll do it. We'll install everything. A gigabyte later. All right. So while that is going, I'm going to take a short break, get another drink of water, and I'll be back in a few minutes. Okay. In addition to water, I also got some apples and cheese. A little early for lunch, but that's okay. Let's get back to this. As you can see, I've got my CUDA installed. Hopefully that means this is all hunky-dory. No, alright, I don't have CUDA art SO.7. Let's just do a quick search on that. Let's see if we can find that. And I found Arch Linux. Whatever. That sounds reasonable. Sure. Generally, if I see a Stack Overflow as a first result in my search for a problem, I feel like that's probably correct. Really? That's interesting. Yada yada. Supposed to fill it out in your path. Maybe it's just another problem of it's not in the path here. Let's Python 2 this up. Right, I didn't activate. /Tensor Flow. Source, I've got my history in Z shell, super easy to search. Go to TF and try that again. There we go, much better. Python 2. Try that. Alright, still don't have that. No such file directory. CUDA art. Maybe a little more specific in what I'm searching for now. Alright, let's try that. What do I find? Ah, someone has a problem in NVIDIA. Try to do this stuff, yada yada yada. Digits, dead server. Cafe root, LD library. You should not have to dig around with your LD library path unless you're in a terrible environment. That's just not. Excuse this command to solve it. Sudo ld config. What does ld config actually do? Configure dynamic link or runtime bindings. Alright, well, let's try it. Well, is that actually where CUDA? Does that actually exist? No! Does that exist? No. Alright, so apparently I don't actually have CUDA installed right now, even though I just installed it. That's interesting. NVIDIA, CUDA whatever, CUDA whatever. CUDA binaries are an opt CUDA. Man, who does that? Oh, you need to relog in. Oh, gosh. What a drag, what a drag. Alright, I should have paid attention to that. So we are going to go on another short break while I relog in and hopefully then we will be running Tensor Flow. On break. Okay, I have relogged in. Hopefully this will make a little bit more sense now. We're gonna see if this actually works here. Welcome back to my desktop. Tensor Flow. Going to TF. Gotta source this stuff. Yes. Open up Python 2. Nope, same problem. Okay, that didn't solve it. So we gotta keep cracking on this. Thankfully, still have all this stuff right here. User local? No, okay, that's not actually there. Like op local? I don't want. opt local? No. Arch Linux, yada yada yada. Python PyCUDA? Is that what I need? No, probably not. CUDA SDK. It's in the repos. Package provides CUDA SDK. People dropping by, please refer to another post for solution. Maybe that's what I want. CUDA's just not seeming to want to work here. That's cute. That's what it provides. Show me the file list. Sure. This big ass thing, you think it'd be somewhere. People dicking around with cafe. It's not exactly what I'm doing. I'm sure it's a related problem though. Installing cafe for digits, yada yada yada. This guy's got the same problem. I don't have user local CUDA directly though, right? No, I don't. So that's part of the problem, perhaps. Opt CUDA. Oh. Alright, so maybe I need this sudo ld config thing. Do it over here. Slash opt CUDA slash lib64. Show me. Yeah. Excellent. Boom. Ah, yes, that wasn't Hunter 2, that was Hunter 3. There we go, much better. Okay. That should be good. See what happens. Nope, same problem. Okay. Is it just not there? Is it like it's not part of my path? Did that get screwed up? Something with Arch Linux is weird. It's not where Tensor Flow is expecting it to live, maybe. Alright, maybe Arch Linux CUDA. Add an Arch Linux to the search. PyCharm doesn't detect interpreter. Well, it's got the right error. It's recent. Two things in its favor. Yeah, I really don't want to dig around with my path. That's just... that way leads to madness. This guy's doing something new. What do people tell him to do? Ugh. God, it's not on Stack Overflow. This is so bad. PyCharm, this is for Windows. Great. Okay. You know what? Hang on. Show me import error. Am I not seeing it where it is? Go down. Is this something not getting highlighted here? I feel like I'm missing something. Dot. No? Where am I bouncing between? Is there an expand all? Oh, this page is terrible. I'm done with this page. Done with it. Alright. Yeah, show me the omitted results. Presumably, this library is located in user local Kevin. See, but it's not. It's located in opt CUDA. Don't know why that is. Don't know why that is. Maybe I should just make a link. That seems like the wrong solution to this problem, though. To link opt CUDA to user local CUDA. Am I vastly misunderstanding how CUDA gets installed? I find it strange that mine is in this opt location. It says right here, hey, I'm installing all this crap to opt. All this stuff. Ah, wait, user. Hang on. No, okay, yeah, user share opt CUDA still. So that's exactly what it says it did, which is reasonable. This guy literally copied them into that directory. I don't think that's a good idea. Let me see about linking these things. Target and then directory. Whatever the thing doesn't exist. I think no, target is the thing that does exist, right? Okay. /opt CUDA /user local CUDA. We're doing it. Oh, hang on. I want to make sure that this is symbolic. Alright. Now I want to see what happens. Probably bad things. Yep, doesn't matter. Great. Alright, let me sudo rm /user local CUDA. Don't want to leave that lying around. Do I need like the CUDA stuff for Python too? Is that it? Doesn't look like it. This is all directly PyRap Tensor Flow, which just happens to need that library. This guy's asking, what do you gain when you copy the user local? Yeah. This guy's saying to copy it. That's frustrating. That this doesn't do what you would think it would do. Maybe the ArchWiki will tell me something. Redirects me, sure. Acquire kernel module. Do I know the right kernel module? For compiling CUDA code, add yada yada yada. So maybe I need to recompile, I guess, because it didn't have it when I tried it. That's possible. Alright. Alright, fine. Pip. There we go. Uninstall. Can I do that? Can I uninstall from a web page? Sure. Great. Pip install again. I don't think it's I don't think it's recompiling anything when I'm doing this. Yeah. Okay. That didn't work. Language bindings, Python. Again, I don't believe I need Python CUDA. Do they have FAQs here or something? Download and set up. I don't talk about this. Alright, you know what? Screw it. We'll go with the CPU version. Right, that's what I was going to do originally. That should not require any CUDA silliness. I want to uninstall this again. Yes, proceed. And pip install. Hang on, I highlighted the whole thing. Bam. Okay. Things are happening. Installing. So we won't have the GPU-enabled version because reasons. But hopefully this version will work. Aha! Okay. Now we're cooking. Tensor Flow. Boom. TF. I'm gonna move that. I hate having the same name. Tensor Flow.py. Okay. Boom. Now we are in. Basic usage. Use TensorFlow. You need to understand how to use TensorFlow. Tautologies are tautological. Turn my computation into the graph. Right. So in TensorFlow, as I understand it, you envision whatever you're computing as a graph. Your nodes are your equations, your transformations, whatever you're doing the data. And your edges, the things connecting nodes, are pieces of data. So you might have multiple arrays going into one node, which means it's like having one function with two inputs. And of course, one node can have many outputs. And this is why this works very well for a neural network, of course. Because every node is a little computation that you're doing in a layer of the neural network. Say, it's got a whole ton of outputs to the next layer of the neural network. And it's got a bunch of inputs from the previous layer. So that makes sense. That's good. Executes graphs in the context of sessions. What's that? Oh, I can't click on that. Okay. Data are tensors, which I will need to read up on a little bit more. In my layman understanding, that has been like a multi-dimensional array or matrix. Maintain state with variables. I'm curious why variables is highlighted and capitalized as though this is a unique, interesting mechanism. Feeds and fetches to get data out of arbitrary operations. Interesting. Okay, we're going to check that out. Called ops, operations, right? All right, everything's a tensor, input and output. Typed multi-dimensional array. Yeah, okay. Batch height width channels, cool. Tensor Flow graph is a description of computations. To compute anything, a graph must be launched in a session. Oh, I see. So that's how they're reaching out to the GPU and the CPU and stuff. The session communicates with that properly. I imagine it compiles, quote unquote, whatever your Python thing is into something that'll run in the GPU. That's cool. Build up your data, assemble the graph, and then you run it. Okay. For example, it's common to create a graph to represent and train a neural network in the construction phase, then repeatedly execute a set of training ops in the graph in the execution phase. Usable in C, C++, and Python. Of course, we're using Python today. I'm comfortable in C and C++ as well. But when I'm doing data science, when I'm exploring data sets, Python makes so much more sense. Then I don't have to recompile everything. Even if I was really good with GDB, and I'm not, it's just much, much easier. And it's like the XKCD import anti-gravity. There's a Python library for almost everything. Granted, there probably is one for C as well. Equivalent functionalities and languages. Okay. Build a graph to start with ops that do not need any input, such as constant. Pass their output to other ops. All right. I think I'm just going to see what kind of tutorials I got. And I'm going to work my way through one of those. MNIST for ML beginners. If you're new to machine learning, recommend starting here. Then with a classic problem, handwritten digit classification, get a gentle introduction to multi-class classification. You know what? Let's just start with the first one, a view tutorial. Okay, yes, we're going to go through the classic U.S. Postal Service problem of people write digits, people have terrible handwriting, but a digit is in some sense an object that you can train a computer to understand. Both new to machine learning and TensorFlow. I have a little bit of experience in machine learning, but not a lot. If you already know what MNIST is and what softmax, multinomial logistic regression. Hey, I do know what that is. Fantastic. I've never heard it referred to as softmax. You might prefer this faster paced tutorial. You know what? I'm going to try the faster paced one. Deep MNIST for experts, of course. Powerful algorithm doing large scale numerical computation. You know what? Let's back it up. I'm actually not that familiar with MNIST itself. I just saw multinomial logistic regression. Aha! Alright, let's just walk our way through this. This is like doing hello world. You know, that better for people? You can see that? 5041. Clearly, I have trained my human learning brain to understand what those digits are. We want to train a computer to do this. It doesn't have to be perfect, it just has to be really good. We're going to do Tensor Flow. Okay. Import data. Import it below directly or simply copy and paste it. Wow, that's incredible. That's impressive that you can just import data. This is a built-in data set to TensorFlow then. Okay. Okay. Where am I? Am I over here? I'm over here. I'm in my text editor. Let me just paste that in over here. You're thinking he's taking an extra step to paste it in instead of just pasting it directly into IPython. Well, sort of. Input data not defined. Yeah, it doesn't surprise me. Does not surprise me. Where the hell do I get input data? Or simply copy and paste it in. Download the code. Oh, I see. I can download the import data code. I gotcha. Damn, that's a lot of work. Can I download that file? That's what I want to do. Bam. Save link as. Perfect. Yeah, we'll save that to downloads. That's fine. All right, let me copy that silly thing. / input data. Proj, TensorFlow. That's fine. It will only exist locally. Module name input data. Right, because that's in TF. That's right. Alright, we'll just move it. This is just all learning here, so that's okay. To TF / invalid syntax. Right, because that's one of these days, man. One of these days. TF / input data. I just wanted the silly Python file. Maybe I need to go here. God, why? Just give me the damn raw file. Why is this? Why you gotta be like this? I don't want to have to like highlight everything in this. That's dumb. Is there a better way? Oh ho ho. Do you have the Python read in all the data thing? It looks like no. Like, it's just annoying that I can't get the literal file itself. What if I do that? What if I go up a level? Yeah, give me an actual file, man. I want the actual literal file. I don't download? No. TF? Oh, hey, TensorFlow. There you go. Cool. Alright, I guess I've just got to copy and paste. That's kind of annoying. Unless I'm misunderstanding something. Is there's something I don't know about Google Git that would make this a lot easier? Like, okay, yeah, I could probably git clone the whole repository. That should have been the way it was in the tutorial, though. Alright. Let's go over here. Let's open a new tab. TF / input data.py, of course. And turn on paste mode. And it just pastes as garbage. And pastes as garbage. Oh no, I did it way too many times. I think we're okay. 285 lines, is that right? Nope, that's way more lines than I ought to have. Undo one set. Paste. 143. Why is this number of lines not correct? Did I lose some lines? This is weird. Did I lose all my new lines? I lost all the new lines. I'm okay with this. That is an acceptable thing to have happen. Alright, I don't really care. The only thing that's gotta, doesn't matter, that just has to exist. Import data, boom, we're in. Let's open it up. MNIST data, that doesn't exist, does it? Oh, it does. Okay, good. Alright, we are working our way through the tutorial now. Don't need this, don't need that. Okie dokie. Downloaded data split into two parts. 60,000 points of training data, 10,000 of test. Obviously, we use the training data to build up our model, and then we'll check it on the testing data. That way we know we're not cheating and just memorizing what every single picture of a 1. Oh, that's a 1. Oh, that's a 1. That's also 1, without understanding what the 1s look like. Alright, every MNIST data point has two parts. An image of a handwritten digit and a corresponding label. Naturally, the image is what we're trying to classify. The label is whatever digit a human thinks it is. Hopefully that's correct. For some of these, it might not be super obvious. We've got 28 by 28 pixels. Cool. This is just a big array of numbers. Here they've got a little, make it a little bigger for you guys. Oh, they typeset in LaTeX. Nice. That's the computer modern font. It's like, if you're familiar with LaTeX, it's super easy to spot. That makes me happy. It looks like they've actually, oh, I see. The image on the left here is far more than 28 by 28. But on the right, they've redone it. This looks like a picture of, like a JPEG of or something, the 28 by 28 original. You can see how this is sort of blocky. But anyway, on the right, they've nicely put in gray. More gray, the darker it is, in what blocks like that. So you can still sort of see the shape of the 1 in that. Alright, they flatten it into 784. That doesn't really matter. Yeah, as long as you do it the same way. The computer doesn't care, essentially. It doesn't know from the get-go. So we just got a bunch of points in 784 dimensional vector space, which is another way of saying you get that many pixels with very rich structure. Warning, computational intensive. Alright, I'll check that out later. Flattening the data throws away information about the 2D structure of the image. Isn't that bad? I admit this thought occurred to me. The best computer vision methods do exploit the structure. We'll go into that later. Alright, so for what we're doing here, that's not going to be a problem. That, yes, we should know that there's sort of a base. This is supposed to be 28 wide, and things that are the same mod 28 are probably going to be close to each other, but we're not going to worry about it. The result is that mnist.train.images is a tensor, an n-dimensional array, with the shape of 60,000 training samples, comma 784. That's how long each one is. That's one image, 784. The first dimension index is the image, second dimension index is the pixel. Yes. Corresponding labels in MNIST are numbers between 0 and 9, inclusive, describing which digit a given image is of. For the purpose of this tutorial, you're going to want our labels as one-hot vectors. One hot vector is a vector which is 0 in most dimensions and 1 in this single dimension. Okay, so we've got this one happens to be a 0, so it's 1 in the first one, 0 everywhere else. This tells you sort of which label this is, giving you more information than you need, but that's okay. So we've got another tensor, as they like to call it, 60,000 long, 1 for each image, comma 10, because we've got this, the value, you've got a 1, these little black dots, that telling you what the label is. So it's maybe 5, 0, 4, 1, in that case. Okay, we're ready to make the model. We know that every image in this is a digit, whether it's a 0 or a 9 or anything in between. Let's look at an image, give probabilities for each being a digit. Yes. Model might look at a picture of a 9 and be 80% sure it's a 9, but give a 5% chance of it being an 8. Yeah, so you sort of got to, for a given image, for a given set of features, compute, well, there's a probability that this is thing A, there's a probability that it's thing B, C, and so on and down forth. That's where we're getting into this multinomial regression. It's multinomial regression. If you're familiar with least squares kind of regression, you're just trying to predict some like rational value given some known information x. So you draw that line. With multinomial, you're not trying to predict a rational value. You're trying to predict a category, generally. that the classic example that I encountered in grad school was you want to commute to work via car or by train or by bus. And so there's a list of factors about each person, like maybe this person makes more money, maybe this person lives closer, maybe they live close to a train station, whatever. And each of those factors will change the probabilities on whether you like to take the car, take the train, or take the bus. And it gets more complicated than that too. But here, essentially, you're trying to model categorical data. All right, what else we got? Tally up the evidence that a given image is in a particular class. Do a weighted sum of the pixel intensities. Weight is negative, the pixel having a high intensity is evidence against the image being in that class. Red is negative, blue is positive. Interesting. I feel like in some of these, I can see what the image, what like, oh yeah, that's a 0, that's a 1, 2, that's a dragon egg, 3, maybe that's a 3. 8, I can actually kind of see an 8. No, that's not all red anymore. Yeah. Okay. That's just kind of a fun image to look at right now. Basically, we're adding up all the pixels for the images that we know are zeros, and sort of we're averaging them together here, and that's kind of what they look like, the positive versus the negative. Okay, but we've got some extra evidence. We'll be able to say that some things are more likely independent of the input. Interesting. The result of that evidence for a class I, given input X is blah. W is the weights, B is the bias for class I, and J is the index for summing over the pixels of our input image X. We then convert the evidence tallies and predicted using the softmax function. Serving as an activation or link funds, shaping the output of our linear function into the form we want. In this case, a probability distribution over 10 cases. You can think of it as converting tallies of evidence into probabilities of our input being in each class. It's not clear to me what... I need to read this bias thing again. Add some extra evidence. Some things are more likely independent of the input. Are they saying that some numbers are... Oh, some numbers are just more common than other numbers, is perhaps what they're saying. And we want to account for that in our model. We're bringing some prior knowledge into this, like maybe ones are more common in zip codes or whatever. You can think of converting tallies of evidence into probabilities of our input being in each class. It's defined as softmax of x equals normalized x plus x. You expand out the equation, you get... this is familiar, yeah. So the different xi's are our sort of like relevant feature vectors for like the bus, the train, the car, and you see it's over the sum of all the possible routes. So like we'll have an equation in xi that'll give us like a number. We'll say e to that number over the sum of e to a bunch of over the sum of a bunch of e to numbers, and that's how you get an individual probability. So the probabilities will sum to 1 for any given individual. So you've got to like 5. If everything were totally flat and we knew nothing about it, we would have a probability of each digit being a 10%, of course. What am I doing? Losing this. 1 second. All right. But it's often more helpful to think of soft expedition input and then normalizing them. That's one way to think about it, sure. The exponentiation means that 1 unit more evidence increases the weight given to any hypothesis multiplicatively. You can picture our softmax projection is looking like the following. So this is all about like building a graph with Tensor Flow, so it makes sense that they're trying this out. Okay, x1, x2, x3. We computed a weighted sum of x's, add a bias. Yeah. Oh, this is turning out to be a lot more useful for this streaming than I would have thought. All right. We've got x1, x2, and x3 are sort of like our different digits. We've got weights on each one of those. Here we've got like three feature vectors, or three features, 1, 2, and 3 to work with. Plus some bias. You crank this through the softmax, and you get out some probabilities. And here's the equation version. That's kind of nice. That's good that you can see both that way. Softmax is the function that makes it all happen. Cool. Oh, and you can think of it as vectors, right? And so you end up with a very nice simple equation. Y equals softmax wx plus b. You should not be surprised that this looks like just a very simple linear equation with some function applied to it equals y. Because for better or for worse, linear algebra is about the only kind of algebra that we as a species know how to do. Alright, so we're going to do this regression. Right, if you're doing computations in Python, if at all possible, use a library that already implements it. Because under the hood, that library is probably using GPUs, or at least something implemented in C. If you rewrite it all in Python, it's going to be slow. And sometimes that doesn't matter, but if you can, it should be fast. Usually, I write it in Python. If I have to write something myself, I do it in Python first, and then while it's taking forever, I'll rewrite it in C or Fortran or whatever. Describe these interactive operations by manipulating some value variables. Let's create one. So we're creating a placeholder variable of floats, rational numbers. We are not passing in the first dimension. We're just saying, hey, this thing is 784 long. Let's do that. All right. Did I get this? I did get that. Bang. What's X look like? Cool. What are the things on X? Graph name. Oh, I can ask for the name? That's cool. What's X set up? What's just X? It just tells me what a tensor is. Cool. That's one of the reasons I love IPython. You can just play around with that, figure that out. Alright, I'm sure you guys are bored of seeing me read all about Tensor Flow. We want to jump in and start doing some stuff. But on the other hand, it's important to understand what the heck it is you're doing, so you're not just banging pots and pans together trying to do data science. That's not data science, that's just banging at the data. Sometimes that works, and that's okay. It's a placeholder, value or input we manage TensorFlow to run a computation, yada yada yada. Here nuns means that a dimension can be of any length. We'll need the weights and biases for our model. We can imagine treating these like additional inputs, but TensorFlow has an even better way to handle it. Variable. Variable is a modifiable tensor that lives in TensorFlow's graph of interacting operations. So there must be a good reason why you don't just literally have an actual Python variable that you have to make a special class for this. And I imagine it's when you build the graph, if this is marked a variable, it's very easy to change and see what changes in the graph. Alright, so we're going to make a variable of zeros. These are starting initialized to zeros. These are our weights. These are our biases. This is, of course, 10 long. The bias itself is only 10 long. Alright, let's see what happens. We're back over here. Bam. Alright, bang that over. Take a look at W. Take a look at B. Oh, I really wish it actually showed me what those were. That's unfortunate. Can I look at that? That's real helpful there. It's so important to be able to just look at what the numbers are, both as a sanity check that, yes, this is what I'm doing, and sometimes you can just see obvious things with the human eye. The human eye, incredible pattern finding machine. Sometimes I like to play a game. Sometimes it's too good of a pattern finding machine. a fun game to play is to make some totally random data, particularly like if it's just zeros and ones, or zeros, ones, twos, threes, fours, whatever, and make just a simple pixel image out of it, and try to find patterns in there. So let's like playing the magic eye. Find the sailboat in there. You have enough data, I guarantee you will find something that you are pretty sure is a sailboat. And you can look at it and you convince yourself that's definitely a sailboat there. How did that happen? You had enough data. That's how it happened. All right, we've got some variables to hold our weights. We've got some variables to hold our biases. That's good. Initial value of a variable. In this case, we initialize a bunch of zeros. We're going to learn them, so it doesn't matter what we start with them. Zeros are a good place to start. W. Our weights are for every pixel and for every digit. We have a different weight. B, however, we only have a bias for each digit, inherently. That's nothing on the basis of pixels. Maybe if we knew that our camera was terrible and that certain pixels were bad, maybe we would somehow bias that, but I don't think so. Now we can define our model. It only takes one line! Magic! Because it's all nice vectorized. It's the magic of Python, one line data science. Okay, so what are we actually doing here? We've got our placeholder information, this X. We've got W, our weights, plus B, our biases. We're doing a matrix multiply, of course. And then move out of the way. We're doing, of course, this softmax, this multinomial regression business. And we're going to get out our Y's in the end. This is just setting up the graph, because again, that's just Y is a tensor. Oh, cool. What's Y 0? Is that a thing? Guess not. What about Y of everything? Alright, that's always fun to learn. Type? Is it a float? Yeah. A float, 32-bit float. Y dot name? Softmax 0. Okay. Well, Y dot eval. Let's type of Y. Alright, whatever. This is flip when we multiply the equation where we have Wx. Oh, interesting. I did not notice that. We had Wx as a small trick to deal with x being a 2D tensor with multiple inputs. It was? I remember. Yes, it is. So it's all about matching up the sizes of an n times n matrix, and then you want to multiply that by an n times k matrix. You want the two on the inside to always be the same. Alright, one line to define the model, a couple short lines of setup. So it's just a nice, because we set it up in this very simple weights and biases, it's easy to do. Again, the biases are just sort of inherent. Oh, we have more zeros than we have ones in our data set. That's kind of a bias. So even with nothing else, you would say, oh, a 0 is probably more likely because I've got a lot more of those, so that's a good thing to guess. Alright. Model can be run on different devices, CPU, GPU, even phones. I might have to check that out at some point. Alright, so now we've got that sort of the graph kind of defined. But we haven't put in our data. We don't have a model that works yet. We need to train the model. One common very nice cost function is cross entropy. Information compressing codes in information theory, but winds up being an important idea in a lot of areas, from gambling to machine learning. Here it's defined. Clearly this makes perfect sense. I mean, this is just an obvious equation, right? Okay, so this y prime, I'm not familiar with y prime, but like the y log y, you'll often see as a measure of what's called like entropy. So if you've got a random string of bits or something, you can say I'm going to measure the entropy by doing this kind of thing. Oh, here the difference is the predicted probability distribution versus the actual. The one hot vector will input. Oh, interesting. What's the I in this situation? Is that for each digit? How inefficient our predictions are for describing the truth. So other things you can sort of, they're climbing on this cross entropy score. In other multinomial regression models, you might climb on, it's called like the maximum likelihood score. So if you're familiar with like least squares, you want to like minimize the error, you can climb on that kind of thing. The problem is when you're not doing least squares, you can't necessarily just turn the linear algebra crank and solve the equation right away. You have to do some more in-depth numerical calculation, which is sort of I'm not sure 100% what this is, what's going on under the hood with softmax. Might have to look at that later. Alright, to implement the cross entropy, we need to first add a new placeholder to input the correct answers. Alright, let's do that. We're using this for y prime or something. This is a weird ending with an underscore. I haven't seen that before. Okay. Okay. Then we implement the cross entropy, which is literally, yes, this y bar thing. And they include the log in Tensor Flow, which is nice. Presumably that's log based E, natural log. It might not matter. It might all probably just falls out in the end. Okay. I defined y. Let's define these guys. TF the log computes the log of each element of y. Oh, it's an element by element of log. Okay, that's why they do that. That's nice. And then it's an element y. It's multiplication of this y bar with y. So that's this part of the computation. This part. And we reduce sum. We do that over all the things. All the things. We sum up all those. Isn't just a cross entropy of the truth in a single prediction, but the sum of the cross entropys for all 100 images we looked at. Oh, I didn't realize there was 100. How well we are doing on 100 data points is a much better description of how good our model is than a single data point. I thought it was like 60,000 and 10,000. Interesting. Okay. Now that we know what a model can do, it's very easy to have TensorFlow train it to do so. TensorFlow has the graph, back propagation algorithm. I want to learn a little bit about this right now. Not a lot. I don't want to go into this too much. Training deep models computationally tractable. Oh, but yeah. Taking a week of training, taking 200,000 years. Yeah. All right. So that's how they're doing the training on this graph. You can read that at your leisure. So train steps. This is the money. Where the money's at. Or is this still building just a graph? Liar choice of automation to modify the variables and reduce the cost. Gradient descent is, I believe, how we're climbing. Maybe that's their back prop. Minimize cross entropy. So that we've got some function we sort of defined, and we want to minimize the cross entropy. Bam. All right. We have TensorFlow to minimize cross entropy using the gradient descent algorithm. This is our learning rate. This is how. It's a faster learning rate. You can go faster, but you might overcorrect. You might overtrain. So I wish they described how they came up with this value. Maybe we'll get to that later. Yeah. Gradient descent just moves the variable a little bit in the direction that reduces cost. Yeah. Other options. So instead of gradient descent, you could use who knows. Adds new operations to your graph, which implement back propagation and gradient descent. Gives you back a single operation. Okay, cool. Now we have our model set up to train. One last thing before we launch it, we have to add an operation to initialize the variables we created. Fair enough. TF.initialize all variables. Interesting. So there's sort of a in order in which you have to do things properly. How we train, how we optimize. Let's go train. Init all var, init all the vars. After defining vars? I don't know if that needs to happen after. They don't talk about it. Here's the session thing. So you make a session. This feels very similar to when you use multiprocessing in Python. You define a pool of processors, and then you run something on them. So that, I suspect, is what's going to happen here. All right. And then we tell it to run right away, which is interesting. So it's giving me 4 threads. I've got 4 cores in this computer. If I had a GPU, I'd probably get a whole bunch more threads on the GPU, and it'd be a lot faster. Name init is not defined. Did I never define this? Whoops. What can I do? Can I sesh.close? Yeah, let me close that. Close that properly. Okay, there we go. I might have some session running in the background. Not a big deal. Not a big deal. In fact, I bet I do. I want to make sure that's dead. So let's just do all this. Bang! Look at that. Look at that Slimeox goodness. There we go. We got my 4 threads. Things are happening. Okay. Now we're actually going to do something, maybe? Yes, we're going to use this mnist, which is our actual data. Let me just copy this over here, and then I'll see what it does. Okay. Fry in range 1,000, so 1,000 times. We will train our x's and our y's. mnist.train.next batch. Oh, 100 guys at a time. I see, we'll take. That's interesting. So we build up the initial model, then we slowly add some more, slowly add some more, slowly add some more. That's cool. That's cool. Where's our... What does mnist look like? mnist dot... Oh, the test set, the train set, the validation set. Okay, that's now I understand. Can I just call length? Is that something I can do? Nope, that's unfortunate. Todd? Images, labels, sure, show me the labels. Oh, I can't get the... I should get a length of that. Interesting. That's 5,000 less than it told me it had. They told me this was 60,000. Unless I'm misremembering, which is possible. Alright, whatever, that doesn't matter. Alright, I like my indents to be 4 long. What are we doing here? We're grabbing our data. Our pixels, our labels. In fact, I want to, no, I don't want to screw with that. Train step, that's how we train. Again, we use this cross-entropy function. Because we're using, the cross-entropy uses the y's, uses the y bar and the y. We define the y as our actual model here. So that's going to get fed into the nice graph. Feed dict. So the x's, this x that is, becomes our backstretches, the y bars, this y bar, which note we made a placeholder, haha, because placeholders are for input. Alright, variables are for internal things we're going to be computing. Now it all makes more sense. And we're going to do this 1,000 times, and I want to add one more thing. I don't know how long this is going to take, so we're going to find out. No, we're not going to find out. I lied. I like to have progress bars because I go crazy wondering, is this done yet? Is it done yet? Is it going? Is it working? Okay. So like there, I was concerned for just a moment, but that took almost no time. Whereas if I saw a progress bar rapidly filling up, no problem. Okay, cool. So I've done a train step a whole bunch of times. So I wonder if now I can look at W. I mean B. Kill me here, man. Kill me. B of 0? Is that something? B of 0, 0? Work with me here. Nope, can't do it. Name. Array B. I don't know. That's something I can do? Nope. Never mind. Never mind. Like B dot. Alright, I guess I can't just fiddle with that. What's going on? Training set, run train step, feeding the batches to replace the date holder. Alright, so we're not iteratively improving our model, I don't think. Maybe we are. Ah. Okay. So it's cheaper to run a bunch of small data sets. Parallelize is better too. tf.argmax, very useful. It's like numpy.argmax, I imagine. You want to know what's the biggest value in an array? Often I don't care what it is, I care where it is. So numpy dot or tf.argmax some array. All right. Stream useful function gives you the next type. tf.argmax y comma 1. Y is once again the model we defined, the sort of output. Do my y's mean anything now? I'd really love to just look at some numbers. That would be helpful, just to make sure I'm not going crazy, you know. Is the label our model thinks most likely for each input? Alright, so let's see how many we got right. That's what we can do here. What's this? tf.argmax y comma 1. It's y comma 0. I want to see this. Great. That's something that kind of frustrates me. If I can't see the data, like here, I haven't actually looked at any of these pixel pieces of data. I have no idea what they look like. That's dangerous. What's this? Oh, that's not right. Like, doesn't support indexing, so dot train, it's some kind of data set. Dot images. Alright, so yeah, alright, that's something. Is it actually something? Hang on. Do I have PyLab here? Import PyLab as PL? That's something? Nope. Import matplotlib .pylab as PL. Alright, I won't be able to make a nice heat plot of that. Alright, well, let's continue on. Ah! I do that a lot using my Vim. Alright, correct prediction. Yeah, what does it actually look like? Cast floating point number, then take the mean. Gives us a lot of bools. Yes, that is what I want. I want to see the bools. Show me the, what do I call list? Does that help? Tensor object is not iterable. Great. Dot set shape, value index. Is it shape? Dot get shape. That's something I can do. Dimension none. That's cute. That's real cute. Maybe I'm doing something wrong. Dimension none. Seriously? Alright, well. We cast under the floats, we reduce the mean. Let's see if we get a number out in the end or if it pukes. Accuracy. Really? Really? Finally we ask for oh, we're just defining things. I see. I thought I was actually getting the numbers, but I need to pull my mind back from I'm doing the computations right there to they exist in this session, and that's how I want to get them. Alright, so now this is all just defining what these are. Define accuracy. This is build model. train. Now, retrieve accuracy. I might have spelled retrieve wrong. That's okay. Bam. Print. Python 2. Why? Why would you do that? There's no reason for that. Ain't nobody got time for that. 0.9128. So that's not too bad. 90% of the time, we were actually correct in what we classified it as. And we just did a simple multinomial regression. Do the same thing in R. You wouldn't be as... I feel like you'd be a little closer to your variables there. You could just poke around and say, all right, what do I got? What do I got? What am I looking at here? That was interesting. Should be about 91%. Hey, huzzah. In fact, it's pretty bad because we're using a very simple model. Small changes, we can get to 97%. Best models are almost 100. Now, in this case, determining if a model is good or bad, you have something to compare to, like, how good is a human at determining what digits these numbers are. Because some people have terrible handwriting, and you're never going to know what number that is. You could pass it to 10 people and get 10 different answers. So I don't think you can realistically expect your machine to do better than that for a task like this. There are other tasks where, yes, maybe a machine will end up being more accurate than a bunch of different people. So 99.7 is probably pretty good. I don't know if that's better than the best humans in this case. Even if it's not, a tool like this will help you triage, like if you're reading zip codes. And in the machine, it needs a way to gauge how confident it is in its result, I suppose. If it's less than 90% confident or 99, whatever, then it kicks that letter out for a human to look at and say, oh, no, that's clearly a 4. They just scratched it out or whatever. Cool. All right. There is another tutorial, but I've been talking for like an hour and a half. So I think I'm going to check out today. Maybe do more of this tomorrow. See what kind of stuff it is. So thank you guys, or thank you, Guy. I did not expect anyone to actually be watching this morning. For listening to me ramble, for showing off my workflow a little bit, for watching me frustrated installing this, but now it works. That's okay. We built a simple multinomial logit model, or logistic. Might be the same, might be different. Those are good models for doing categorical data. Again, if you're taking the bus, if you're taking the train, if you're taking your car. Or is it a 0, is it a 1, is it a 2, is it a 3? Something where we're not just estimating a float. My sense of Tensor Flow right now, I like being closer to the data. So I'll have to try this more with this building the graph thing and then having a session run it, defining the variables I want to run, and then having the session run those to get it back. I would rather just run the data, or run the function, and be able to have my numbers right there in front of me. To me, that's very important. That I can just explore the data, I can make sure something's working, I can do an engineering quick calculation in my head, am I even on the right order of magnitude? Those kinds of things are very valuable. So we'll see. Maybe it'll be fine, maybe it's kind of weird. But it's very new. And I did see on GitHub they're planning to come out with Python 3 version. That'll be great. I'll be very happy to have that. Have all my useful things. And maybe TensorFlow will end up being great. I appreciate, however, that it's not just another neural network tool. It's a tool to do a more general type of analysis using these graph constructions. And maybe as I learn it more, I'll come to really like it. All right. This is, I guess, formally called Dan Does Data. TensorFlow. Thanks for listening, guys.